Hello, and welcome to this pre-recorded event. We will now look at the requirements and practices associated with the 6 GRO4 course, entitled Commercial Design, which is completely different in approach to the 6 GRO1 course. To help you get the most out of this feedback, you may want to have these following documents handy, as we will refer to them during the session. The 6 GRO4 course in graphics focuses on a synoptic task of a student's own choice and offers individuals the opportunity to demonstrate the skills and competencies assimilated during the entirety of the course so far. In this course, students are required to work on a single integrated design and make task that reflects how a professional designer might work in dealing with a design problem and its resolution. They have free choice of design task, but must work with an identified client or small user group in a commercial manner, seeking feedback and consultation at a number of stages in the design and make process. It's a requirement that students should consider sustainability during the design process and the impact their product might make on the environment. Work is presented under the headings shown on this slide. Before commencing this task, students need to negotiate an appropriate problem choice through negotiation with their teachers. There are demands placed upon centres for this submission, and more information can be found on page 111 of the specification, which is highlighted here. Candidates must choose a project task that fits either of the two pathways, conceptual design or the built environment, shown here. Candidates must also evidence the design development and manufacture of a 2D and 3D element to their products, or to an associated by-product. There are a number of possible product outcomes or topic starting points that can be chosen under the headings of the two pathways, as shown here. Here we see a number of final products, exemplifying the type of products you may find in the concept design pathway: vehicle design, a train carriage with advertising stand, the 2D element, point of sale display and packaging for chocolate bar, the 2D element being the external graphics on packaging, and a concept model of a children's camera with packaging, where the 2D element again is the external graphics for the packaging. Here we have a selection of examples of built environment products. The lifeguard lookout station shown, positioned in its intended environment, with a back-to-client board exemplifying what the final design will look like. This incidentally is designed and developed as a separate product. We also have an interior design product, in this case without a 2D element. This would incur a reduction of marks in the design, development and manufacturing sections. Finally, we can see an exhibition standard to launch a new fruit drink, where the 2D element is the graphics for the packaging on the drink pouch. The start of the A2 Commercial Design coursework requires a clear analysis of the problem to be demonstrated. It is important that the candidate shows that they understand what they will need to face through the presentation of a clearly laid out set of questions. Here, we see 3 samples of work. The first, a fairground ride, with its needs justified through information established through external means, in this case, an article on the BBC website. The second has the central need driven by a user of the product, in this case a parent and young child, for the design and development of a children's camera. Finally, we have an architectural product being designed for a specific client, who in this case is also the user. Any of these approaches are suitable. What is important is that there should be a discussion with a third party to demonstrate working in a more commercial manner as a designer. Upon the establishment of a series of questions or pieces of information to be found out, The designer then has to undertake research to establish the answers to these questions. The research pages in a high-achieving submission should be used. Research undertaken for no reason will not connect to the analysis and provide little help in the forthcoming specification formulation. Here, we see research being undertaken to establish the needs of the user in an interior design project. The effective use of product analysis, ergonomic research for the camera, realistic site research for the placement of the footprint of a building, and finally, the application of important technical information in other products for an architectural design assignment. It is important that research feels realistic and needed. To do this, it needs to relate back to the questions being raised in the analysis and be relevant to the problem identified at the outset. Here, we have a selection of research pages from a variety of projects, from architectural to packaging. They are not as useful as the pages previously seen, as they do not realistically help the designer in establishing the key issues that will form a specification. Questionnaires that have too little focus on the issues or real problems raised in the analysis of the brief. Research that reads like a straight copy from a textbook, assuming the need for certain materials is common prior to any design requirements being penned at all. Finally, the use of the mood board, a series of pictures of products, with nothing extrapolated from the pictures. Greater depth of explanation is needed, and there is no evidence that designers in any of these examples understand the problems they are facing and are simply undertaking formulaic and expected research. It is essential that a strong specification is developed, as it will be used to guide design ideas and check their viability as they progress. Specification points should also be used during review, develop, and evaluation of the final design proposal, as well as testing and evaluation of the final practical outcome. A specification should be organized logically, and this can be achieved by using subheadings such as purpose, user requirements, performance requirements, materials, components, size, safety and quality, scale of production, and cost. Specification statements should be technical and measurable wherever possible, so students should ensure that there are several points made under user requirements and performance requirements, as these headings are where such points are made. Specification statements should also be justified to explain why they are relevant to the product. Sustainability should be included in the product specification, and this may refer to the environmental impact of extraction, use, and disposal of materials. Students should present evidence of using research and of having consulted with the client to ensure that specification points are mutually agreeable and that they meet the needs identified earlier. The slide shows two examples of good product specifications, where there is evidence of technical, measurable, and justified statements and reference to research. This is a good example of a specification, but specifically in this case, the candidate misses the opportunity to insert some easily measurable points in terms of the size limitations for the camera and ergonomic access to the buttons, etc. When designing initial ideas, students are encouraged to use their creativity to produce a range of alternative designs that address the problem in hand and conform to the product specification for both the 3D and 2D elements. Students should present a range of alternative ideas that are realistic, workable, and are annotated with technical information on materials and processes that could be used in the actual products. Detail within the design work can be evidenced through the demonstration of ideas for the individual subsystems in the design work. As it progresses, each design idea should be evaluated against specification points to check its viability. Subjective statements should be avoided. Comments must be justified to say why a design meets or fails to meet specification points. Client comments should be sought at this point. Client consultation should always be a feature of designing initial ideas and the decisions involved in the establishment of a final solution. The slide shows alternative designs for a theme park ride. The work is explained and evaluated. Detail is offered in forms of the individual key component requirements and explanations of how the ride would function and how technical needs would be met. This slide shows examples of architectural design work. The buildings are being designed from their external aspects only. The work shows 3 different approaches to generating ideas. Initially, we have the use of external natural inputs using images as a design strategy. This is then taken onto a modelled stage, creating the outline structures of buildings in rough modelled shapes. The other example in the top right of the page uses interior restrictions and external architectural concepts found in product analysis to drive the ideas for the designer. What is now required in a later development stage is the use of technical input to demonstrate how the buildings could be made to work. This may involve the use of extra research, which is probably best presented at this stage. In this example, we can see 2 different design sheets. One is an interior design layout, showing too few changes and too little technical information. The second example is for a caravan design, with again too little detail. Here, we are shown simple external body shapes, with little opportunity being taken to explore the design needs or technical input. In all these cases, there appears to be little evidence of client or user group input. To make the work feel more realistic, the client should be given opportunity to provide input at various stages. The project will have an artificial feel to this aspect if the first time the client has actually seen the project is the final presentation at evaluation, as in the case here. This instance of packaging design, in this case the 2D element, had a great deal of client input throughout the presentation of the design work. Some detail is offered, but not necessarily of a technical nature, which is probably more appropriately presented in other subsystems of this design work. However, the client has had a real input on the decision-making process, and it is clear that third-party input has affected the design decisions. This is realistic commercial designing and helpful in providing the right effect for the candidate. The point of the review section is to encourage students to review their completed alternative design ideas against specification points and against one another in order to determine which is the best fit and should be taken forward for development. Review should be presented formally rather than consist of comments tagged onto design ideas. Comments should be objective and relate directly to specification points, especially those that are measurable and performance-related. Review statements should include reference to sustainability, and detailed client feedback should be sought. The results of this section should be summarized to explain which design and which features from other initial ideas are to be taken forward for further design input and development. The slide shows 3 different methods of presentation of this information, only one of which actually looks specifically at the specification points, the ice cream packaging. That said, if the other 2 had focused their comments to the specification points in particular, then this would have been credited. The better reviews would involve all or a number of these types of presentations. This would allow for specification review, third-party input, and summative decisions being examined from a designer's point of view as well. In the development section, students are required to develop a final successful design proposal based on the results of review and in consultation with the client. The 2 and 3D elements also have to be developed. Development means change, and this should be illustrated by students through their ability to bring together the best or most appropriate features of the design ideas into a coherent and refined final design proposal that meets all the requirements of the product specification. There must be evidence of the developed design having moved on from an original idea through the results of an evaluation and testing and client feedback. It is not acceptable to simply take an initial idea and make superficial or cosmetic changes, and then present it as a final developed proposal. Students should include as much detailed information on all aspects of their developed design as possible. This is an opportunity to show knowledge and understanding of their design and make activities, and to illustrate the gains made through advanced studies of graphics and the materials and technologies associated with their field of study. Modelling is an important aspect of design development and should be used to test features such as proportions, scale, mechanical details, subsystems, etc. Modelling can be done through the use of traditional materials or through 3D computer simulations or rapid representation techniques. Evidence of real-world modelling should be presented through clear, well-annotated photographs. Whatever method of modelling is adopted, students must make clear how the results of these tests have improved or taken on their design afterwards. Here, we see this principle applied to the development of a children's camera. This slide shows the development and changes taking place in the finalization of the proposal for the 2D element of the children's camera. The logo developed is to be placed on the packaging and the front shutter of the camera. It is clear to see changes being trialled, and the decisions have been documented along with external reviews from the user. The slides shown here form part of the development of the seats and the mechanical aspect of a fairground ride. The seats utilize traditional modelling with experimentation on how to make and finalize their manufacture, whilst the mechanical aspects of the ride are trialled with modelling kits. The changes are documented and reviewed, with a proposal made later. Here we see some good development of a building, with technical information and further research being added, and minor changes being made to a considered proposal. The building is then modelled and viewed from various angles, then reviewed by the client or users, with key developments being identified for further exploration. The development section needs to end with a presentation of a final proposal. The work can include further technical information, but really needs to include some form of evaluation and reasoning behind the decisions that have led to this proposal. Marks are awarded for the quality of communication in design, review and develop, and students should present their work in this section using communication skills of high quality. Most students are skilled users of ICT, and it is at this point that the use of 2D and 3D CAD would be appropriate in displaying design details and features using the power of ICT. Communication skills are important in conveying ideas and should reflect the gains made 1 year on from AS studies. Students are encouraged to use any appropriate means of illustrating their work that they are comfortable with, as long as the results are clear and easily understood. Effective annotation is an important feature of this section in enabling students to explain details of design thinking and to offer evaluative statements regarding their design proposals and the needs of the client. In planning, students are asked to produce a detailed production plan that explains the sequence of operations that their product will go through during manufacture. A work order or schedule should be produced, and this could be done in the form of a flowchart or table, which should include the order of assembly of parts or components, tools, equipment, and processes to be used during manufacture. Planning statements such as turn on lathe or bend wool to the correct angle would be of no help to anyone trying to follow the plan. Statements must contain quantitative information such as how many holes of what diameter must be drilled and what angle must the wool be bent to. Planning implies the consideration of time, and it is essential that references are made to timings and deadlines during manufacture. If a Gantt or time chart is used as part of this section, It is important that students only chart activities relating to the manufacture of their product, and not the whole of their design activities. Time should be recorded in hours or minutes, not in lessons, weeks, days, or dates, as these units give no indication of real time. Quality control points should be identified and quality checks should be described to say what the checks would be, how they would be carried out, and what equipment would be used. Questions such as, "Is it the correct size?" or "Is the corner a right angle?" are questions, not checks, and cannot be credited. Similarly, safety checks should be considered as part of planning for manufacture, and these must relate directly to the manufacturing activities of the intended product. Students should realise that planning is a forward-looking activity, and this should be reflected in their use of language. The term, "the next step in the sequence will be," implies an activity that will occur in the future, which is appropriate. However, to say, "the next step in the sequence was," is a statement implying an activity that has already taken place, which is retrospective, not part of a plan, and cannot be credited. The Gantt charts seen here are almost of no assistance in planning for the manufacture. Here, they are limited in detail and have too little specific application of time or quality control. It is often easier to present the work in a table format, where the quality control, detail, time, and health and safety issues can be more formally laid out. In the making assessment criteria, students are asked to produce a high-quality product that meets the requirements of the specification and fully matches the final design proposal in terms of function, sizes, finish, etc. The quality and complexity of manufacture should reflect the gains made in skill levels 1 year on from AS work. The range of processes should refer to a range of relevant advanced processes commensurate with this level. During manufacture, students should demonstrate their understanding of a range of materials by selecting, using, and justifying those that are appropriate to their needs in terms of properties and working characteristics that were detailed in the specification and work plan. This is often completed in the folder, often alongside the final design or exploded view with annotation to explain material and construction choice. Students must show demanding and high-level making skills in order to achieve the high category of marks in the making section. So, it is essential that the product under construction offers enough complexity. The level of complexity will already have been established at the design development stage, so it is important that students who have high potential are guided towards appropriate levels of response at an early stage in their work to ensure success. Marks in the section headed Use of Tools and Equipment are gained for demonstrating skills and competencies in manipulating tools and equipment when manufacturing component parts of a product. For high marks, practical work should show high levels of skill resulting in precision and attention to detail. The slide shows a very comprehensive set of photographs, or diary of making, which illustrate clearly a wide range of skills and processes that demonstrate precision and attention to detail. Importantly, each image is annotated to describe what is happening. It is not a requirement to take as many photos as are shown on the slide, but those submitted should show the skills and processes that justify the marks awarded. Where a student uses limited or repetitive skills that are simplistic, higher marks cannot be achieved no matter how well the skills are used or how well the product turns out. The product and skills used must be appropriate to A2 levels of response. While Edexcel encourages the use of new manufacturing technologies, the use of CAM should not exceed 50% of manufacture. Over-reliance on CAM does not allow students to fully demonstrate a range of personal manufacturing skills. In order to score high marks in the section headed Quality, students must produce a product that is well assembled from component parts, is fully functional, matches the final design proposal, and is appropriate to A2 levels of expectation. If a product is assembled from component parts that have been made using only moderate levels of skill, but were well assembled into a fully functioning product, which matches the final design proposal and is appropriate to A2 expectations, then high marks can still be achieved. Where a student fails to reach higher levels of credit in use of tools and equipment, this does not mean that they cannot achieve higher marks in this section of making. For high marks in this section, students must justify the selection of materials used and say what qualities or properties make them suitable for use. As evidence of the quality of manufacture, clear photographs must be submitted that show enough detail to support the credit awarded during centre assessment. As photographic evidence is the only proof of manufacturing quality, it is essential that the images convey levels of difficulty and complexity of construction. It is unlikely that a single image will achieve this. A series of photographs taken over a period of time during manufacture is the ideal way of highlighting processes used and providing examples of precision and attention to detail that may not be readily noticeable in an image of the finished product. Marks for complexity, level of demand, are awarded for the challenge presented to students in making their product. High marks are achieved for evidence showing a range of demanding skills and processes. Extended help from teachers or technicians and overuse of CAM will reduce the level of challenge to a student and will inevitably reduce achievable marks. Where processes have been outsourced because of limitations of school facilities, this must be taken into consideration when marks are awarded. Where a student goes off-site to do specialist work, this is acceptable as long as there is photographic evidence to support any work done by the student, and the teacher provides a witness statement as proof that the work was genuinely that of the student. On this slide, we see a working roundabout model with working app. The presentation was sent for assessment with a disc that contained a video clip of the ride in operation. When the product is completed, students must test and evaluate the outcome to check its fitness for purpose. The finished product should be tested under realistic conditions to determine its success. Measurable performance-related points of specification should be used during testing, and tests should be described to say what is being tested, how tests were carried out, and what the results of testing were. Where only limited performance-related criteria were included in the product specification, testing will inevitably be limited and simplistic. Testing must be objective and should include detailed feedback from the client, who provides comments on the same specification points as the student to ensure objectivity. Photographic evidence of testing should be submitted to support tests carried out. Evaluative comments should be made by both student and client to justify how specification points have or have not been met. Marks out of 10, or ticks and crosses, should not be used to judge the success of a product when set against specification points. There should be discussion to justify comments. Information from testing, evaluation, and client feedback should be used by students when making suggestions for modifications and future improvements to the product. Suggestions for modifications should focus on improving the performance of the product or its quality, and should avoid superficial cosmetic changes that are wholly subjective. Life cycle assessment should focus on a student's product or part of the product and should avoid generic information that could apply to any product. Effective testing and evaluation can only be carried out if a product is complete, so it is essential that students refer and adhere to their work plan to achieve the planned time for this activity.